everyone. Thanks a lot for coming down today. I really appreciate it. This is a subject that I'm very passionate about, and I also acknowledge that the title doesn't really mean anything. So I'm really happy that you come down just to see what it is that this even means. This is how I make money every day with my consultancy, building these video pipelines. And unfortunately, there's no word that really describes what this is. So I'll try to run through it all so that you have a better idea of what it is. So a little bit of background about myself and M9Y. I'm a self-taught web developer. I just followed my own interests and built apps for myself and things that I wanted to see. One of the first apps that I built was called That Was Pro, which is a software as a service for Twitch streamers. It allows them to connect to their Twitch account and download their videos, and then manipulate them in the video editor so that the gameplay is in a landscape clip, but they want to trim that to be portrait mode, but they want to change where their camera position is, so put that at the top, add their username as a watermark down the bottom, and then render that out so that they can share that on social media, grow their channel, but also have attribution at the bottom of their video so that they don't have to worry about people stealing their content. As I started building this, I kind of just assumed that there was technology out there that allows you to define what you want a video to be like and build up kind of this pipeline. But as fortune would have it, the day, or within the first couple of weeks, I should say, as I started building this product, I saw on Product Hunt that there was a product called Remotion that launched, and it was built exactly for this kind of thing where you want to build a video editing interface, build a video pipeline. So I started using that. I started participating in the Discord, asking questions, answering questions. After a while, I offered to be a moderator in that Discord, which they accepted. People started asking me for help. I then quit full-time work and became a freelancer, just offering Remotion services. And then I worked with Remotion, the Remotion core team themselves, built out a Google Cloud platform rendering pipeline that other people can download and use for themselves. And yeah, now I'm the #3 contributor to the Remotion open source project. And yeah, that's how I make my living now, which is, it wasn't planned, but I'm really happy it's worked out that way. So, programmatic video, what does that even mean? Well, if you think about watching something like the AFL, where there's the score up in the top right corner, somewhere along the way, that's just like a database somewhere that's saying that what the scores are. And when it flicks out and shows goals, points, total, all of that is code, which is looking at data and then putting that in the appropriate columns and then defining that animation of how it should appear, when it should appear, yeah, and like the colors and all that kind of stuff. Another really good example of programmatic video is weather reporting. So each night when they do the news report and then they do the weather and there's a person standing in front and they point to all this stuff here, that's not someone that's like dragging an icon looking like, oh, Port Hedland was sunny today, click sunny, add that icon, type in the temperature. That's just like an API. It hits the Bureau of Meteorology, pulls that data in. It's got latitude and longitude details, which will then place it on the map. And then you can use animation libraries, or you can define the animation yourself to make these really cool graphics. You can decide to zoom in and zoom out when a person talks, all kind of things like that. So that's what I mean when I say programmatic video. Now, there's two components to this. One is like an automated video pipeline, which is completely hands-off. A good example is if you were like a stock market influencer and you wanted to churn out a daily video about the highs and lows of the stock market in a certain niche that you're experienced in, you could build this video pipeline that hits some stock market database, pulls in that data, shows red, shows green, depending on what happened, shows the different numbers depending on whether it's up or down, and then hook that up to like the Instagram API, and you've got an automated video pipeline. And whether that's good for the world or not, I'll leave that up to you. The other side of this is if you thought this is such a good idea that I actually want to build this as a SaaS. So I want to build this as a SaaS so that other people out there that want to flood Instagram with stock market videos, they can choose the font that they want, they can choose their branding colors, they can decide how many stocks to show. And you build out what is essentially a video editor. And this is the part where it gets pretty tricky for me, because people say, what do you do? And I say, well, I build online video editors, but it's not like DaVinci Resolve or anything where there's all these drop downs and different options to choose from. It's like you've got a niche use case where your users want this type of video, and for them to get from A to B to the point where they've got the video, they only need 4 buttons. And I would say as few buttons as possible is where you're going to make a really good app for your users. So this is what you can do with programmatic video. You can build a bespoke video editor that can trigger an automated video pipeline where the data that's coming in is dynamic, or that dynamic data could just be coming in on like a daily schedule. So we're here to talk about mobile apps though. And I'll be straight up. I've never built a mobile app, but what we're talking about is databases. We're talking about a cloud rendering pipeline, and we're also talking about showing the animated visuals within your app. So I'll get to all the parts of the tool chain, which you can use within your app. So I think there's a lot of data available in the treasure trove that I've depicted here of your B2C app. A really good example of this is Spotify Wrapped. I'm not sure who's familiar with that here, but at the end of the year, Spotify will give you a summary of all your listening data. Most importantly, it'll compare you to the whole user base, and it will paint a story where you're very proud of your use of the app, you're very proud of your own listening data, and it will say like you're the top 1% listener of Taylor Swift, something like that. And then what people do typically is then they post that to social media, and then other people see that, then they say, oh, I want to get my Spotify Wrapped and show that I'm the top listener of the Eagles or whatever. And so then they'll share their video as well. And the effect that this has is that Spotify, every year around Christmas time, Spotify app will literally jump up the rankings for the number of app downloads, because people get FOMO, or people want their own Wrapped. They've been using it in some other platform or something like that. So this has a real business outcome. And I've included this one here from Substack. In my opinion, it's not very good. It's like, let's hit the database and get the data, and kind of that's all they've really done. I think it's really boring. It doesn't tell a story. And what we're going to try to do is use that treasure trove and not end up with this dog's breakfast, and we'll get a video out of it, because what the social media engines want is, the social media algorithms, they don't want text. They certainly don't want a link in the text to your app that's just going to get buried in the algorithm. I think they're okay with an image, but they're not stoked with it. But what the algorithm's really hungry for is a video. So we want to be able to render out a video for every one of your users, or more specifically, every one of your users that requests a video. We want to render that out really cheaply, and we want to render that out really fast so that it can be on demand. So that's what we're going to try to talk about today. So let's have a real quick example here of programmatic video. You might think that what we're looking at here is just a slide deck, but it's not. It's actually, I'm using the tool Remotion. I'm using the video preview. It's called Studio. And what we're seeing here is actually 30 frames per second rendered on the fly. And we're seeing 60 frames of that. So we can see that the current frame is currently, jumping from 0 to 60, and it's just on a loop. So if I pause it, it'll stop. And if I keep going, it'll keep going. And we want to be able to define these animations. So we want to say like where the elements would be on the page at certain frames, and where they should, where they start and where they finish. And if we're going to create the illusion of motion, which is what a video is, we need to define all those frames in between as well. But it would be a lot of work if we said that, let's have this box at position 60 at frame 0, and then we'll go to position 340 at frame 40. It would be so much work if I had to program frame 61, frame 62, frame 63. So what we can do is Remotion gives us these functions to interpolate between these values, so that we know at, I should have chosen some nicer numbers for mental maths, but we know where it should be at frame 20. But what we can say is interpolate between, And now we can see that we get the illusion of motion because at every single frame it's updating where it should be on the page. So Remotion has, I wouldn't say it's a flaw, but I would say that there's better tools out there. The problem with Remotion is that it is defining everything within the frame is defining through CSS, which is what we use to build web pages. And what CSS is really good at is drawing rectangles. You can change like the border radius so it looks like a circle, but at the end of the day, we're just positioning rectangles around the screen. And if you want to create something that looks super duper fancy like this, you're going to have to get really creative, and it's going to take quite a bit of development time to try to think about like, how can I make a rectangle do this on these certain frames and go around this path. And I just want to have a quick moment to talk about like what design means for a business, in my opinion. So if you are using an app and it has really nice design, that's a signal to your users that you cared when you built the app. And your users, when they decide to give you money for your app, that's like that's a trust transaction. So if you can say, I cared when I made things look good, I cared when you clicked on here and the error message didn't cause the page to like jank, and then you probably think that I also cared when I was thinking about the security of your database and thinking about how to handle your financial details as well. And that builds up the trust. So to me, design is an integral part of web development. I know there's some developers I work with who don't really care for CSS and design, but I think it's like an integral point. And if it's not something you're super strong with, you should at least pair with someone who believes in that. So how do we build really, really nice animations? Well, this is another tool in our tool chain. We've already talked about Remotion. This one's called Rive, and Rive is it's a vector animation library. So it allows, or a vector animation tool and editor. It allows you to have like a lot of freedom with drawing shapes, a lot of freedom with building state machines to define animations, and also have animations triggered by user input, so that, you know, when I click on this, it does this little thing, or when I click halfway through the animation, it needs to do something else. The editor is really good at building these interactive animations, but more importantly, it's very performant. And when you use the native runtimes that it gives you, it's able to render out these vector graphics very, very fast. So you can make things look like this without too much effort, and you don't need a really high-end device either to display that. So I thought I'd throw up a really flashy Rive animation. So this one is rendering live, as everything here is rendering, and we can see that there's some raster images in here. We can see that there's like transparency. So one of the niche use cases that Rive seems to be targeting, judging by their marketing material, is UI and heads-up display in video games. So this one here is piping in data. I mean, it's not actually, but you can imagine that it would be. It's piping in data from some kind of external logic into the Rive animation. So we've got things like the ammo that the player has, the health and the shield, some kind of timer, I'm not sure what that is, the current weapon, and also like this map display of where people are. So you've got all this logic that's like computing what's happening in the game, and then you pipe those variables into Rive, and then it's able to display them. So hopefully this gives you an idea of where we're heading when we're talking about getting the data from your database, using Rive to make things that look awesome, and then displaying them on the screen in a way that's really engaging. And the really cool thing with Rive as well is that we're piping in variables, but we can also pipe in events. So I can actually fire this gun here, and then you can see it like cool down. And yeah, it's a really cool tool. And like, I don't know, I've just got a MacBook. It's fairly powerful, but it's not out of control. So yeah, here's a list of Rive runtimes. The one that I'm most familiar with being a web developer is the JavaScript library, which we'll talk about a little bit. But also you can chuck it in your Unity and Unreal Engine. It would be like for the use case that I just showed. But also you can throw it in Apple and Android, Flutter, React Native as well. So this is this example here is a live Rive animation, This is one that I built for a customer called Gladiator Tennis at the end of 2024. So Gladiator Tennis is an app where they organize championships and like seasons within certain districts in America. So you sign up to the app. I don't know exactly how it works, but I imagine you get a ping. You go to the tennis court that it says you should go to, and you meet someone else there. You play a match. You both put the data in the app to say who won, who lost, what the score was, and then it will it'll build up, I don't know, some kind of knockout competition or something like that, and then you can be crowned the champion of your region. So yeah, this Rive animation is live right now, so we can click on it. Let's go in, and we're piping in the data for a certain user here. We can see at the top, we've got these, the animations that you would typically see in like a Instagram story or something like that. And we can also interact with it, click forward, click backwards, just like you would expect. There's a really nice animation just here. Yeah, so you can make things look really cool, and you can actually interact with them as well. And what we went with for this one was this final screen where it shows all your stats, and then you can click share, and that pops out an image that you can then post to social media, post to say, look how awesome I am at tennis, but also I happen to be using this Gladiator app. If you like tennis, maybe you want to get that as well. We've got the data that comes in from the database. Then we want to build this really nice animation with Rive. But as I mentioned earlier, we don't really want to share, as much as I showed you the Gladiator campaign where we shared the image. That's not really ideal for the social media algorithm. It's much better if we can share a video. So in terms of Rive, I propose that you discard the idea of interactivity, and we think about building out just an animation that is deterministic, so that every time the 20-second mark comes around, the animation looks exactly the same at that point. So it's not like we're clicking and interacting with it, and every time 20-second rolls around, it could like be showing something slightly different. We want it to be deterministic. So we've got a live coding example here. We can see this ball bouncing. So this code is currently running through the JavaScript advanced runtime. It's using the basketball.rive file. A lot of this logic is just boilerplate. So, and to be honest, it's just like copied and pasted from the doc. So there's nothing too scary here. But what we want to look at is the way that this render frame works. Just trying to make it. Yeah, so here we go. So the first time that it loads up, it calls the render frame function. It runs through and it renders a frame. And then it recursively calls itself. So it calls render frame again. So what you're stuck in is this render frame loop, which is where it's showing every single frame here, and it's giving, as I've said before, it gives the illusion of motion when it's actually just like frames showing up one at a time. So how is this working? Well, this is really the main line we want to look at. We call animation.advanced on the Rive file, and we want it to move forward by a certain amount of time. And then because of the recursive nature, we just want to keep moving forward by that amount of time. So what we could do here is halve that. And we can see that it goes slower, halve it again. We can see that that animation keeps slowing down. So every time it's jumping through here, it's going to advance by a certain amount of time. But what we need to do when we're talking about rendering out frames with Remotion is we want to be able to say, go to this frame and like stop. Then Remotion can take a screenshot, and then it can store that as a certain frame for the video, and it can go to the next frame, and then it can build up all the frames for the video. It uses FFmpeg to stitch them all together, and you end up with an MP4. So instead of looping the render, let's not. And now we want to display frame 64. So before, when we were recursively rendering, I had this bit of logic here. If we want to loop render, we'll call yourself again. But if we don't want to loop render, just run through this just once. So the logic is, how far into the animation are you? And you call animation.time. So, I mean, at this moment in time, we know that we're at frame 64. at 30 frames per second, I don't know, somewhere over 2 seconds. So we know we're there. And then we say, what is the delta in time? Like, we want to go to this target seconds, which is the target frame divided by FPS. So we end up with the target seconds. What's the difference between the target and where we're at currently? Well, that's the delta, and that's how far we want to advance. So we can change frame 64 to frame 65, and it moves forward by 1 frame, and then Remotion would take a screenshot and we end up with a video. I'm not going to spend too much time on this slide, but what this is doing is really just the exact same process, but this time we're using a hook in the Remotion package to say what is the current frame, and then we're doing the exact same logic. We're saying, what frame were you at? I know it's not that fun to look at all this garbage, but we want to say, what frame were you at? What frame do we want to be at? And advance it by that time in seconds. So if you recall, this whole slides that I'm presenting is rendered on the fly, and I've made this one last for, I can't remember, 320 frames. So if I pause it now, we should see that the animation stops, and we can jump through like that. But if we actually jump out and look at Studio as a whole, we can see that this animation is now deterministic. So this is the timeline for the Remotion video. And so every time we jump to frame 175, the animation looks exactly the same, which allows us to render out and create a video deterministically. This is where things get a little complicated, but I show you that the Remotion documentation is really solid on how to actually render these videos out. And the best way, in my opinion, to render these videos out is using what's called Remotion Lambda, which uses AWS Lambda functions. I think due to time in this talk, I can't really give you like a full background of what a Lambda function is. So I'm really hoping that the majority of people here understand that it's just like this stateless little function spins up, disappears, and it has no relation to the other Lambdas. So what we want to do with our process, if we just take a bit of a step back and think about the journey we've come on. So first off, we have built the animation in Rive. It's not interactive, so every time a certain second of the animation is displayed, it looks exactly the same. We can put that in our app, like that job's done. Every time, and we pipe in the data from the database. So every time someone wants to look at their Spotify Wrapped kind of thing, it has like this really cool animation, uses their data, they feel cool. But we want to give that to social media in a video format. So that's why we brought in Remotion. That's why we broke down the render loop for the JavaScript runtime. That's why we then hooked it up to the Remotion frame number. So now we're at this point where it's deterministic in Remotion. So now we need to render it. But rendering is not necessarily expensive, but it's not free. So if you've got a user base with like tens of thousands of users, one thing you could do is just say, this sounds complicated, I'll just render it for everyone. But then what happens is 20% of your users actually want to share it and the 80% don't care. And well, then 80% of your rendering costs have just gone out the window. So that's no good. So we want the user to be able to say, to view the animation, which is where we're going to use the native app runtime, and then click a button and say, yeah, I want to share this. But at that point, you don't want to say like, I don't know, request received. And then like an hour later, they get an email that says that their video is ready and they don't care anymore. So we want to be able to deliver it to them very fast. So what this architecture allows us to do is deploy a Lambda function that is capable of just rendering chunks of frames. And we can say we want to render, let's say it's quite a short video, 30 frames per second, and it goes for 210 frames. And then we say, well, let's render out with Lambda and we'll put 21 frames per Lambda function. So they all spin up in parallel. And then this one renders frame 1 to 21. this renders frames 21 to 42, etc. And then they're all able to render in parallel. And then all those little chunks of images all go into an S3 bucket. They all get stitched together. That part's really fast. You don't have to worry about that too much. And then you've got your MP4. But there's a lot of different levers here. This is the part that can get complicated when you really want to say, I want to be deliberate with balancing my cost and performance of my rendering solution. So maybe we're happy that 10 Lambdas get spun up every time someone requests a video, but our AWS quota is only 100. Well, that means only 10 users can render concurrently. And then the 11th user asks to render. And well, I hope you've deployed a queue at that point so that they can sit in their queue. But then we're back to the problem of rendering on demand. So luckily, you can just ask AWS to raise your quota. It's not super simple. They don't just like give it out willy-nilly, but it's not too bad. So you can raise that quota. You can massage your frames per Lambda. This is definitely a little complicated. You can change the concurrency per Lambda. So what happens when the Lambda rendering engine spins up is it actually opens a headless instance of Google Chrome, and depending on the number of processes that have been assigned to that Lambda, that's the number of tabs you can have open in that Chrome browser. So not only do you have concurrency across your different Lambda rendering functions, you have concurrency within each Lambda, so they could be rendering four tabs in the Chrome browser at the same time as well. But then you've got like diminishing returns because then your Lambda's fully overloaded and it's like slowed right down. And yeah, so these are like a lot of levers that you need to create some tests, run it multiple times, because Lambda rendering is not like, it's deterministic in terms of the output, but it's not deterministic in terms of how long it takes to render. So sometimes it'll render a little bit faster, sometimes it'll render a little bit cheaper. And with the Lambdas, you get charged basically per second that they're up. So you want to have them running, you want to have them up for as little as possible. So one of the ways you could have them up for as little as possible is increasing the memory, because then they've got more RAM and more power, so they can render faster, but then it costs more money to raise the memory per Lambda. So this is yet again another lever that you have to pull to try to change. One thing that you should definitely do is if you've got rich media, so you've got like images or video or music in your animation, because these Lambdas are stateless and they have no shared state between them, if this Lambda has to download your 500 megabyte movie because it's in frame 10 to 20, and this one also has that 500 megabyte video in frame 21 to 30, well then both of these Lambdas are going to sit there idling while they wait for that download to complete, and that's going to be time that you're charged for. And you might actually, due to your composition and display of the video, maybe that video is just like really small and it doesn't have to be 500 megabytes. So you should do some effort up front, optimizing your assets so that all of these Lambdas are downloading the smallest size possible. This is obviously something you think about in app development in general, but it plays a big role here when it's like spread out across hundreds of Lambdas at the same time. So this is, stepping back from all of this, you might be thinking like it's kind of overwhelming. And I just wanted to give you an example of something that I've deployed just recently for the video game Rainbow Six Siege. It's unofficial. I would like it to be official, but Ubisoft never contacted me, unfortunately. So the way this works is you can enter your Ubisoft ID. You can choose whether you're on the Ubisoft platform, Xbox, or PlayStation Network, and then you click generate. What happens behind this is an iframe to my website, actually, by the way. If you want to try this yourself, it's m9y.com/r6. So when you click generate, it's going to go off to an edge function. It's going to call some Ubisoft APIs and pull in the user data for this plain milk user. It's going to run through some calculations that I've made myself to try to tell a bit of a story with these statistics. I don't want to just say like, you got 100 kills. I want to say like, you suck when you try to do this thing or something like that. Some kind of funny story. So it's when I click generate, it's going to jump over there. It's going to run those calculations, pull that data back in. And then what we have here is the Rive runtime running on my website. natively, I guess is a way to put it. And you can download it here. So that rendering time it didn't just render it in like a second flat. What it did was it saw that I'd already generated the video for this user. It saw that video existed in S3, and it just provided the download link. So this is another thing. I mean, this is pretty obvious low-hanging fruit, but like if a user requests to render the video and it's already been rendered, don't let them render it again. Just give it to them straight away. The iframe clogs this up a bit, so I've made this button here so I can see it full screen. I just want to take a little bit of time to talk about, in my opinion, how to create like a really, really good campaign like this. So what I've aimed for here is, number one, it's fairly short. It's a 20-second loop, but all of the individual animations are all occurring on different cadences. So when you look at this, you kind of, first off, you see this and your eyes kind of dart around, and then you go, I'm just going to watch this one for a bit and see what's going on there. And then you watch the next one, you see that animation, have a look at that, and then the next one, et cetera, et cetera. And before you know it, when this is, you're viewing this on Instagram Reels and you're looking at your friend's reel, you've actually watched it like 4 times and the engagement rate's gone through the roof, even though all we did was render a 20-second video and we didn't pay for 80 seconds worth of rendering. We didn't make the user wait for 80 seconds worth of rendering. So this is a way that we can, I guess, game the algorithm to try to make these things more engaging. The other thing that I aimed for here is not giving, I do have a bit of an issue with the animation here, but it's maybe this is like more of an Australian thing, I guess, but like we don't need to only show positive stats to the user. We can like poke fun at them and tell them like, when you play the game this way, you're actually not very good, but you continue to try. And that's, again, part of this storytelling aspect and makes people think like, this is funny and yeah, this is something I would share. It tells a story. I post this to social media, people comment and they're like, yeah, you do that, idiot. That pretty much wraps it up. These links here, obviously M9Y is my website. There's contact details there. I really am passionate about like programmatic video. So if you would just want to talk about that for any reason at all, please contact me, talk to me here, ask a question later. Rive is the animation library, which makes things look super pretty and awesome. Really good community as well. And Remotion.dev is, Remotion is like just been really important for me and my career as well. And the guys that are running that are just super generous with their time, and yeah, I'm really grateful to those guys as well. And last but not least, I'd like to thank Adapter for having me here today. So yeah, thanks a lot.